My name is Vishnu. I'm Solutions Architect with Akamai here.
Good morning, everyone. My name is Divya, and I also work as a solutions architect.
All right. Before we get started with this topic, how many of you moved to the cloud recently? All right. So today's topic of discussion is going to be performance and scalability with the application load balancer Cloudlet. How many of you have heard of Cloudlets at Akamai? Have you guys been to the Cloudlets club downstairs? All right, that's good. So today's agenda is going to be on the following. We first look at the challenges with the current origin architectures. Then we'll be talking briefly about what Cloudlets are and what are the current available Cloudlets with Akamai. We'll be introducing the application load balancer Cloudlet. And we'll be discussing a couple of use case scenarios. We'll be talking and comparing the ALB Cloudlet versus other Akamai products which were available and almost have the same feature set. We'll be talking about the differences and why ALB Cloudlet is better. And then we have a UI demo where we'll be showing you the steps in order to get you set up with the ALB Cloudlet. All right. So what are the challenges that you face today with your end users? Final goal is to provide the best end user experience, but then at the same time you're trying to mitigate downtime risk associated with unreliable data center health. You always face a challenge of having to scale infrastructure for your growing end user base, and generally, when you're dealing with multiple data centers, you have different load balancing strategies. And when you have different load balancing strategies, that definitely introduces some latency. You could either place this entire logic at your Akamai network, or you have it within your data center. Now, data centers, two kinds. You're looking at cloud today. Half of you maintain most of your applications on-premise, or you're partly moving it to the cloud. On-premise and cloud. Now, how do you maintain a balance between this? How do you serve traffic, or how do you direct traffic to your on-premise infrastructure or to the cloud? You're looking at microservice architectures these days. Why? Because it reduces time to market. It also reduces, it's more scalable. It's easy for your DevOps teams for maintenance purposes. And in combination with private and public cloud offerings, the entire setup becomes a little more complex, a little more complicated to maintain. Now, when you're trying to deal with on-premise infrastructure and cloud, and you're trying to route traffic or trying to maintain some kind of load balance strategies, having to maintain this on your infrastructure or on your cloud would actually induce a lot of latency. For this purpose, okay. All right. Some top business goals driving cloud investments today are reduce cost of ownership, enabling business continuity, and replacing your on-premise infrastructure, of course. And now, as I said, it's a combination of on-premise and cloud offerings. And to help you with this transition from on-premise to cloud, we have something called the application load balancer Cloudlet. We do have other products at Akamai which could help you with the same, but this is something that we brought in recently to make it completely self-serviceable to you guys. It's very easy to use, but before we get into details of what the application load balancer Cloudlet really is, let's talk about Cloudlets. Now, why did we introduce Cloudlets? Back in the days, it was your Akamai representative who was coding the entire business logic for you guys on the Akamai network. And then we introduced something called Property Manager, which was completely self-serviceable. And you could configure your business rules on Akamai from your end. Then we thought of actually offloading business logic from your applications and bringing it onto the edge. And that's where we formulated the entire concept of Cloudlets. So Cloudlets help migrate your business logic onto the edge. Now, what are the advantages with this? You reduce end user latency. It's very easy to use. And in case you want to deploy changes, the turnaround time is about 10 to 15 seconds. Some of the common Cloudlets, these are the Cloudlet offerings today. We have Edge Redirector, Vista Prioritization, API Prioritization, Face Release, Request Control. Some of the commonly used Cloudlets today amongst these are Edge Redirector, where you actually offload your entire redirect setup from your application onto the Akamai service. Vista Prioritization, we have the holiday season coming up. You'll be seeing surge of traffic. And with that, we actually help you handle flash crowds, traffic surges at the edge server itself. We make sure that we show a user-friendly page. Instead of directing the traffic to the origin server, we make sure we throttle a certain percentage of the users and show them a user-friendly page. So Vista Prioritization Cloudlet is for cases where you want to handle traffic surges. Audience segmentation. A lot of you guys actually have A/B testing going on. You're looking or experimenting with different experiences, end user experiences. To handle this kind of traffic and to maintain stickiness across different experiences, we have something called the Audience Segmentation Cloudlet. Our latest Cloudlet offering is the Application Load Balancer. We went into general availability with it recently. We'll be talking about different use cases and the features of the Application Load Balancer in this presentation. We have a Cloudlets club downstairs where in case you have any queries or questions about any of our Cloudlet offerings, we have our representatives seated there. Just walk in and you'll have your questions answered. All right? Nivya?
So, working now? Can you hear me? Okay, what we're going to be talking about now is the Application Load Balancer Cloudlet. This Cloudlet is completely scalable and uses intelligent routing in order to be able to perform traffic management across either your private data centers, your cloud-based data centers, your public data centers, etc. It's also capable of automatically detecting load conditions across your data centers and route traffic to the most optimal one at any given point in time. It can do all of this in combination with honoring your custom routing logic and also maintaining visitor sessions as well, which is something which is fairly important to everyone. So the Application Load Balancer Cloudlet can maximize the application's performance and availability with fast, flexible, and reliable load management across the Akamai network. So at its very core, the Application Load Balancer Cloudlet is capable of combining the attributes of both your application layer as well as the DNS layer to perform your routing logic. So it can route across your different data centers by making use of this information. So the Application Load Balancer Cloudlet has 5 different capabilities. The first one being session stickiness, which I'm assuming is one of the most important criteria when you're trying to maintain stickiness between an end user and a given data center. The way Application Load Balancer will do it is by making use of cookie-based stickiness. And it does that in conjunction with the Akamai CDN, and it also has IPv6 capabilities. The next one that we look at is also fairly important, which is origin health checks. So the ALB Cloudlet or Application Load Balancer is going to periodically check with the origin to see if it's up or not during any given interval of time. If at any point in time we determine that your data center is down, we are capable of splitting traffic across your remaining data centers, which Akamai assumes is currently up. In case all of your data centers are down, We can also route your traffic to a custom failover page on net storage. Basically what we're trying to say is that we can serve out a maintenance page to your end users. The next one is no hardware, no code. You can offload all of your routing logic onto Akamai and let us take care of it. Right? You don't need to maintain any sort of code or hardware on your end, which will be responsible of taking care of this logic. The next one is fast, intelligent routing. This is where SureRoute comes into play. With SureRoute in the picture, in conjunction with our CDN, what we're capable of doing is ensuring that an end user that's making a request to your website is always routed to the most optimal data center using the most optimal path. And that path is also always available. The last one is that it's easy to set up. It's simple to configure and manage. You have a UI, you can also make use of APIs for it. You click and design and get your rules in place and you're good to go. And you can also ensure that you have specific operational staff which are in charge of each of your cloudlets. You can allocate the level of permissions to each of them. So what we're going to talk about now is the steps to get started with the entire thing. What do you need to have in place before you get started with ALB, and how do you configure it? The first one is that you will need to have your net storage files in place. When we're talking about this, what we're talking about is your maintenance page. What do you want to serve out to your end user if all of your data centers are deemed down? The next one is that you will need to create an empty ALB policy, application load balancer policy, and save it. All of this will make a little more sense when we go into the UI and the demo piece of it, but we're just walking you through it so that you understand it from a use case perspective going forward. The next one is within your delivery configuration itself, you will need to enable ALB and also mention what your origin endpoint definitions are. Where does Akamai need to route an end user traffic to? Where are your data centers located? All of this information will go into your delivery config. What we have next is managing your load balancing setup. This is a tab that you have within the Cloudlet itself. This is where you will create your routing strategies. Saying data center A is located in a specific location, you will put in your latitude and longitude. Your other data centers, you will just mention where they are located. You can set up liveness test as well. So all of this will go within your Cloudlet. The last one is to update your ALB policy to let it know which load balancing strategy to use. Please feel free to stop me if you have any questions. I know it's a lot of information. What we're going to look at now is a couple of use cases. The very first one is one of the most common ones that we see is a 3 data center setup across the United States, where the most important pieces are that they're all running active-active. Session stickiness is important, as well as failover in case one of the data centers go down. So when you configure application load balancer, you will have a rule and an associated load balancing setup. Your rule is your match condition. It can be any HTTP based condition, say where the user is located, what path they're trying to access, whether they come in with a specific cookie, what device they're trying to access with, etc. So based on these conditions, we will decide what load balancing setup to use. In our scenario, what we have in here is 3 data centers, one in New Jersey, one in San Francisco, and one in Chicago. So the ask is that we route an end user to the most closest data center to them, the most optimal one. Now, since the end user in this scenario is making a request out of New Jersey, it makes more sense for us to route them to the New Jersey data center. So the way the entire execution is going to happen is that we're going to match against rule A based on the HTTP conditions, saying, for example, they came in with a specific cookie or the fact that they're located in New Jersey. The load balancing setup 1 will come into play now. And ALB will say, route this end user to the New Jersey data center. The next scenario is also very similar, where the end user is sitting out of San Francisco. Now the execution is the same again. We match against rule 1. We decide that the corresponding load balancing strategy 1 comes into play, which is to route the end user to the San Francisco data center. The last one is when the end user is sitting in Chicago, they make a request, follows the entire process again, and gets routed to the Chicago data center. Now ALB will set cookies for you, so that you can maintain stickiness for an end user. Now, in the first scenario, when he was routed to the New Jersey data center, in a corresponding request that they make, they will stay sticky to that specific data center. Now, let's look at a scenario when one of the data centers has gone down. So, ALB offers you an option of turning on automatic failover. What this means is, if automatic failover is turned on and a specific data center goes down, we will automatically start splitting traffic between your remaining data centers, which is what's happening in this case. Now, say that you have automatic failover turned off. In that case, ALB gives you an option to decide where you want to route traffic to. Now, if the New Jersey data center was down, where do you want to route that end user to? For example, you want them to always go to the San Francisco data center. And that decision can be made via ALB for you.
All right, let's just pause here. Any questions with respect to, yeah? You'll have to speak out a bit.
I want to test New Jersey before I put the real traffic on. So how do I send the tester traffic to New Jersey when it comes up?
So you want to test traffic? Yeah, I will. All right, I got your question. So the gentleman's question here was, New Jersey goes down. We start routing traffic to San Francisco and Chicago. But what if I have to test New Jersey once it comes back up before routing real user traffic back to the engine data center, right? That's your question. So we could configure specific rules on your Akamai delivery configuration to make sure we route traffic specifically to the New Jersey, San Francisco or Chicago data center. We could make sure that the failover delay, like the failback delay rather. So once New Jersey comes back up, we maintain an enough time window to actually route traffic back to New Jersey once it's back up. We could increase the time window during which you could actually have some testing done at your end. Does that answer your question? Yeah, perfect.
What we could also do is that based on a specific cookie, we could always route to a specific data center. A specific cookie or a header can also be used to force traffic to go to a specific data center. That is how you could test before you actually start sending traffic across.
Any other questions with respect to the capabilities? We discussed 5 capabilities in general. Yeah. I'm sorry?
Control the ramp-up time for each data center. Like, let's say I'm using AWS resources that auto-scale, and I want time to ramp up so that when auto-scaling takes effect. Can I control how long it takes for traffic to get there?
So you want to ramp up traffic slowly?
Yeah, so instead of saying, bam, it's back up, and now you get 30%,
Okay.
I want to say, you get 1%, 2%, 3%, you can ramp up over 45%.
Okay. So the gentleman's question is about, let's say something goes down and once it comes back up, you don't want to send like about 40 or 50% of traffic straight away to the data center which just came back up. How do you slowly ramp up traffic? Well, we could make use of APIs in that case. So we have API support for the ALB Cloudlet. Now in this case, we could slowly make sure that we start out with a lower percentage and head to wherever you want to be for that particular data center. I think that would help out. So so you are asking what support we have apart from cookies? We'll be looking at that in the demo. We have a bunch of options available, but thanks for your question. So his question was, what capabilities do we have to maintain session stickiness apart from cookies? We'll be discussing that during the UI demo. All right. Any other questions? Cool. All right, let's head to another use case, a little different. We're talking about a hybrid setup here, a combination of on-premise and cloud. All right. A part of your traffic is being directed towards on-premise. the remaining of it to your AWS instance, non-critical traffic. Let's say you have a banking website. Most of your traffic is being handled by on-premise. Let's say your marketing content is being handled by your AWS instance. Common asks, session stickiness. If you're going to on-premise, stick with on-premise. If you're going to AWS, stick with AWS. Failover. Now let's say your on-premise infrastructure goes down, you should be able to reroute your traffic to an alternate data center, right? And vice versa. And in case everything goes down, let's show them a maintenance page, okay? A slightly different ALB setup from what Divya showed you. Last time we had just one rule, but here we're looking at two rules. Rule A takes care of directing traffic towards your on-premise infrastructure. Rule B takes care of routing traffic to your AWS instance. Now, you asked based on which HTTP criteria, the gentleman? You asked based on which HTTP criteria we can route traffic. We have a bunch of criteria available. We'll be showing you during the UI demo. So let's assume your client is making a request for the login page. Now, this is a critical resource. It's being handled by your on-premise infrastructure. And since rule A is associated with all traffic for your on-premise infrastructure, that gets picked up in your ALB Cloudlet. Rule A is associated with something called load balancing setup 1. Now, load balancing setup 1 is strictly your load balancing strategy for your on-premise infrastructure. Another user is making a request for a marketing page, a non-critical asset. All of this is handled by the AWS instance. It matches against rule B, which takes care of AWS routing. Rule B is associated with something called load balancing setup 2. So you're maintaining two different load balancing strategies here. Setup 1 for your on-premise, setup 2 for your AWS instance. Sorry, okay. Now, let's assume data center 1 goes down. What happens? We reroute traffic to data center 2. What happens if data center 2 goes down? Also, then we route all the traffic either to AWS. Upon request, we either transfer all those to AWS, or we redirect them to net storage. All right? Similarly, if your AWS instance actually goes down, that's pretty rare, but still, if it actually goes down, then we would still reroute the traffic to net storage. All right? Any questions with respect to this scenario here? Okay. Now, I spoke about other Akamai products. So we have ALB, we discussed its capabilities, but these requirements have existed over the years. We had products which could handle these. How many of you have heard of Edge Load Balancer? All right. Do you use Edge Load Balancer even today? All right. GTM, Global Traffic Manager. Cool. So first we'll compare ALB and ELB. Next I'm going to compare ALB and GTM. Why? We're looking at layer 7 first, and then we're looking at the DNS level. So application load balancer, completely available to you in a UI. Completely self-serviceable. ELB on the other hand has to be coded either by an Akamai representative, very complicated to change in case requirements change from your end, and time to market is quite high compared to what ALB has to offer. You make a change, it's live in 5 seconds. All right? It went into general availability recently, and we have brought our Edge Load Balancer Cloudlet to a close now that we have ELB out there. Otherwise, we still have customers who still use ELB. So do you think this is a good candidate for you? Okay. Next, GTM. GTM, you could use it for routing traffic across your different endpoints. But what exactly does ALB bring to the table that GTM doesn't? One, you have HTTP rule-based policy routing. Now DNS, we usually look at the end user's location, geographic location, but you never really were able to match against HTTP criteria until today, which is available to you again on an UI. Near zero configuration, just a couple of clicks before you can go live with your changes, or in case you automate it with APIs, it's instantaneous. Affinity and sticky sessions. With GTM in the picture before, we were successful at dividing or making sure you have equal weights of traffic to different endpoints. But now with session stickiness and HTTP based capabilities also introduced, we make sure that apart from just maintaining or dividing load amongst your different endpoints, we maintain sticky sessions as well. Automatic request retry. We don't decide that the data center goes down just based on a couple of failures. We make sure that we actually retry multiple times before we actually assure you that the data center goes down and start rerouting traffic. We also keep checking in the background to see if your data center is up or not, and accordingly start dividing traffic again. Right? I'm going to pause again over here. Any questions with respect to ALB features or the differences with existing Akamai products? Yep.
How do you gracefully tell the ALB, instead of using the automatic request retry, to say, you know what, I'm going to take this one on maintenance, but it's not actually going to be down in that sense. So I want to tell the ALB, don't run any more new traffic to this, so that when the session dies for the user, then routes into the next.
So you have 3 endpoints, one goes down, and you don't want to read.
One goes down.
None of,
I take them down because they are going to in maintenance mode because I need to fix them.
so they go down as in you actually manually bring them down.
Yeah.
So you would actually send 0 traffic to them?
Yeah, I wanted to tell the ALB proactively, hey, through the API maybe, hey, I don't send any more traffic to this data center because I'm going to do some maintenance in this cluster.
In this particular time window. Okay. That exactly is not available within the ALB Cloudlet, but okay, I'm sorry. The question, so gentleman here wants to actually manually bring down a data center for maintenance or testing purposes. So how do you gracefully tell the ALB Cloudlet to not transfer any traffic to this data center during this time window? Okay, so he wants on-demand traffic routing depending on when he actually brings his site up or down, and that again I would say we would have to make use of APIs. So you actually direct your ALB policy to so you essentially what you're modifying your load balancing strategy. You have a traffic split, let's say 30-30-30. Now you're making it 50-50 because you're actually testing on one of your data center endpoints. All that you'll have to do is change the split numbers and you're live immediately. Changes to go live 5 seconds, right?
Some responses. So if I have a region that starts spewing errors, can I then retry those requests on a different region?
We would. I mean, for the same request?
Same request. Yeah, catch the error, catch a 503, and try a different region. Catch a 404, try a different region, try a different origin.
So, okay. So his question is, how do we detect error responses from one particular data center and start rerouting them to another data center? That's what it is. Okay. So that's why we have something called liveness tests. So what liveness tests actually do is make asynchronous requests, background requests. Apart from your regular end user requests, you have some background requests going on which periodically check the health of your data center. Now in the case that you're seeing a lot of 5xx or 4xx errors, right? You see a lot of 5xx errors, we actually determine that this data center is down. We could manually even fire an alert. I'm sorry, do you have a follow-up question?
Yeah, I want to look at the actual responses my users are getting, not just what my liveness test is.
So your users would actually be redirected to an alternate data center. Why? Because we had already predetermined that this data center was down based on liveness tests.
My liveness tests are succeeding, but I have certain transactions that are failing.
Okay.
I will be able to trap them as errors and then redirect them to specific transactions.
Yes. So
That is possible. So we spoke about automatic failover earlier. So that does the same thing. You will mention that 5xx errors or 4xx errors are your erroneous conditions. So based on that, you can either choose to split traffic between your remaining data centers, which is when automatic failover is on. If it is off, you can choose what data center you want to route that traffic to. Yeah, when we go through the demo, we'll have like specific screenshots of just that. Yeah, no problem. Okay, what we're going to look at next is our demo. The very first step that we spoke about earlier is setting up your net storage files. Next, we get into the actual implementation of it. The very first step is to create your ALB policy. The reason why this is important is so that you can reference it within your main delivery configuration. So you will go into creation of your Cloudlet policy. You will choose the type application load balancer. You will name it whatever you want to name it, but make sure you remember this name so that when you go back into the delivery config, you can reference the right policy. You will also give it whatever notes you want just so that you can remember what the policy is for, and you will choose what group you want to associate this with. This is also very important. Make sure that your delivery config and your Cloudlet policy are in the same group. The next step that we have is to add ALB within your delivery configuration. Based on whatever match conditions that you have, you can choose to invoke application load balancer Cloudlet. So the very first piece is the policy name. This is the same one that you named it in the very previous step, which is why I asked you to remember what the name was. The next piece, my bad. Okay, so the next piece is the instance label. This is what is going to distinguish your cookie between different, say, instances of application load balancer that you have within the same delivery config. This is the tag that is going to be associated with your application load balancer cookie and which will be used to maintain stickiness between any given data center. Yeah. The next thing that we have is origin stickiness. How often do you want us to check whether an end user needs to stay sticky with a specific origin? How often do you want us to refresh that session for you? So you have several different options in this case. As you can see right here, you can choose to set the cookie every single time an end user makes a request. So basically every time an end user hits your site, we will reset the cookie for them. The next option is that it's permanent, so it stays on the browser and only dies out if they get rid of the cookie or if they restart the browser. It expires on browser close. When the session ends, the cookie also expires. You can also choose to expire it at any fixed date or time. You give them a specific time, that is how long your session's cookie is going to stay valid for. The last one is expires after a duration. Say that you want your cookie to be valid only for 30 days or 1 day or 7 days. That can also be mentioned within your ALB configuration. The next piece is when all origins are down. Say that all your data centers are down for whatever reasons, maintenance, outage, etc. What do you want Akamai to serve out to an end user in that case? Where do you have your failover page configured? So this is your net storage location, where the static page is located, and what response code do you want to give to an end user? Some of us wish to show a 200, some of them want them to know that it was a 5xx error. You can configure it as you want it to be set up. The next piece is failover management. This is what you are asking about. So what Akamai will do is it will let you configure what response codes you determine as down for the origin. In this case, what we have done is put in 5xx response codes. If Akamai, for whatever reason, sees any of these 5xx errors, it will say that your origin is down now and let's go on to failover. With automatic failover handling on, we will simply split traffic between your remaining live data centers. If you turn this off, this is the option that you will see. If a specific origin is down, where do you want us to route that traffic to?
This is the answer to your question, sir.
Yeah. The last piece is cached content. What we're asking you here is the directory structure between your different data centers the same? Can we cache all that content similarly, or is there a distinction between all of them? So this is what goes into your delivery config. The next thing is to define your data center endpoints, right? Just like you would do in your default section within the config of specifying what your origins are, so that ALB can call out to your specific origins, you will need to reference them within your delivery config as well. So what you will do is you will add a rule called Cloudlet origin group. If any of you have used a Cloudlet that makes use of an origin endpoint, this is something that you would have seen before. What it does is it's giving a tag or a name to your data center, and this tag is what is referenced within your ALB Cloudlet. In our case, we chose to use two different sets of origins. You will define what your origin is, what are the conditions that it needs to establish a connection with your origin, what is the host header that it's expecting. If the configuration is secure, do you want to pin certificates? What kind of SSL connection do you want us to establish with the origin server? You can also choose to set up different CP codes, which is something that we recommend. Yeah. So these are the two different data centers that we have set up.
Thanks, Eva. Okay, so we discussed 3 steps so far. I told you in the beginning, or Divya told you that it takes just 5 steps to set up your ALB configuration. Just to quickly recap, all that we have seen so far is your property manager UI. You first created and saved an ALB policy. Second, you enter your property manager configuration. You define your ALB policy. Third, you define your origin endpoints. Here you have one GCP and one AWS. That's what we've reached so far. Now this is where we start entering into the ALB side of things. This is your ALB UI. First, we define what is called your load balancing setup or load balancing strategy. You see your manage load balancing setup, and then you see another tab called manage Cloudlet policies. We are going to look at that in the next slide, but this is where you actually define your load balancing strategy. First, you define something called the balancing type. Now, what is balancing type? We have 2 flavors available, performance and weighted. When you actually select performance, what that actually does is route your traffic to the most optimal data center based on the end user's geographic location. All right? And when you actually choose weighted, it makes sure that it maintains a hard limit with respect to traffic split across your different endpoints, right? Next, we define your 2 data center endpoints. Now, how do you actually associate what you had in your property manager config in your ALB policy? That's where Divya talked about tags, origin tags, Cloudlet's origin definition. So we defined something called Edge Demo AWS. We had 2 endpoints, AWS and GCP. We reference the same 2 endpoints within this load balancing setup. We define the traffic split. We check the box if it's a cloud service. Now, why do we actually need to know if it's a cloud service or not? Cloud, usually the IP, the end IP constantly keeps changing. And to make sure that the DNS TTL is maintained a little lower than your regular on-premise infrastructure, we make sure that we just enable another option out here for you. Next, we determine the geographic location of your endpoint. In this case, our AWS was situated in Singapore and GCP in the US. We mentioned your actual latitude and longitude information. The reason being, we have selected the performance flavor of load balancing. If we had selected the weighted, we would simply mention the traffic split and we would maintain a hard split across the different endpoints, right? Next, and if in case you're looking at adding an additional data center, all that you'll have to do is go back to your property manager config, define that endpoint, and then reference it out here for you in your load balancing strategy. Next, we're looking at liveness test settings. I spoke about asynchronous requests, background requests, where we actually check the health of your data center, origin center. This is where we determine criteria for your liveness tests. What is the URL going to be? What is the host header going to be? On what port are you going to make a request? What are the failure conditions for your liveness test? So if you look at this, we determine the protocol, you have a port option. How frequently do you want to run your liveness tests? Usually these are very lightweight requests, so we maintain a low interval of 15 seconds. So we constantly update ourselves about the health of your data center. Next, what is your timeout duration? Then what is the path for your liveness test? And then finally your failure conditions. Sake of this demo, we have turned off failure for 3xx and turned it on for 4xx and 5xx errors. Usually it's associated with server-side errors, mostly 5xx, but just turn it on for 4xx and 5xx here. Any questions with this slide? All right. I'm sorry. Yeah. So zero response is something like a TCP connection timer. So his gentleman's question was, what happens when you don't see a response at all? Now, there are two scenarios for that. One, where you're not able to establish a TCP connection itself. Or two, you're able to establish a TCP connection, but you're not receiving any response headers. Right? The two kinds of timeouts really. Both of them end up being 5xx errors on Akamai. All right? So those fall under that window and it's all taken care of. Right. All right. The last slide, the last step, really. This is where this is your UI for the ALB Cloudlet itself. The previous slide was looking at the load balancing strategy. This is where you actually set up and associate HTTP based rules to your load balancing strategy. So this is where you define which part of your site follows which load balancing strategy. So you start out by defining a name. I'm sorry. Okay, start out by defining a name. I've placed a bunch of criteria out here for you. Protocol being HTTP, I've made it site-wide, and then I look at a certain request header called live test just for testing purposes. And then in the end, you just make one decision. What is your load balancing ID? This load balancing ID is what we defined in the previous slide. As you can see here, I've created 3 or 4. What I showed you in the previous slide was edge demo perf liveness. And here you're actually associating a HTTP rule to a load balancing ID. This is a drop down of all the options available under this section. So you can do it based on different request criteria. Gentlemen, this is your question, right? With respect to what conditions. You could definitely look at the user location data, path, method, any of the request criteria out there. All right. That brings us to the end of the presentation. We have a live demo for the ALB Cloudlet in the Expo Theater for you guys. Apart from that, there's also a Cloudlets club, which is going to be handling queries on all the Cloudlets out there and any questions regarding the ALB Cloudlet as well. All right. So thank you guys for your time.